So for this question, if we have an if it was an unmagnetized steel, if it was a magnetic material, it will be attracted. And it will always be attracted by induced magnetism. Like if one side you was having soft iron and another side you was having an unmagnetized piece of a steel, like which was not magnetized. So what will happen? Because both are magnetic materials, so magnetic materials are always attracted by the magnet. So this will have a north and south, and this will have a south and north, and both will be attracted. Because magnetic materials are always attracted by the magnet. If it was a permanent magnet, one side it will be attracted and the other side it will be repelled, because when opposite poles are facing each other, there will be a there will be attraction. When like poles are facing each other, they will repel each other. So this is always attracted. So if you have a piece of iron and you place close to a magnet, induce magnetism. So what pole should be induced? South. And what pole should be induced? North. And what is the direction? Because it is attracted, so the direction of the force is towards the left hand side. If you have the same piece of a soft iron and you place on the right hand side, so what will happen? North pole will be here and south pole will be here, and the direction of the force will be again to be attracted towards the magnet or pulled by the magnet. So magnetic materials are always attracted by the, what can be said in strong attraction, the strength of the attraction depends on the strength of the magnet rather than a material. So if a magnet is very strong, yes, definitely it will have a stronger magnetic, like greater force on that. So strength mainly depends on the magnet rather than a material. Is it clear, this question?
Yeah.
Okay. In which device is the magnetic effect of the current is not used? Electromagnet. If we have an electromagnet, when we pass the current, when a current is passing through a wire, it produces a magnetic field. So current produces a magnetic field. No, the question is in which device the magnetic effect of the current is not used. Like current produces a magnetic field and we are not using that effect. But in an electromagnet, we use that effect. When we pass the current, there is a magnetic field. When there is no current, there is no magnetic field. So we do use that. A loudspeaker, how a loudspeaker works, loudspeaker also use a magnetic effect of the current. So a cone of a loudspeaker, like this is representing the cone of the loudspeaker. And there's a thin membrane is there. Maybe you have seen this. This is a thin membrane. So what will happen when the current, there's a strong magnet here in the center of this loudspeaker. And when the current passes through, an alternating current passes through, so it causes the force on the membrane in and out. That force which is produced in and out, that causes a vibration or produces a vibration, and that vibration produces a sound. So we use the magnetic effect of the current. Like whenever there's a current, it produces a magnetic field. The magnetic field of a current interact with the magnetic field of a permanent magnet, and it experience a force. This causes a vibration of the cone in the loudspeaker. That's how the loudspeaker works. A potential divider. Potential divider is a series circuit. When we divide the voltage between the two components, depending on their resistance, that is called a potential divider. If I have a 100 ohm resistor and I have a 200 ohm resistor and I connect them with the supply, so when I connect them with the supply, the voltage will divide between them. This does not use the effect of the current. This use the effect of the resistance, because the ratio of the resistance decide what will the voltage or the potential across each component. So in a potential, even D is not the right answer. C is the right answer for this, that the potential divider circuit does not use magnetic effect of the current. Relay, what is a relay? Relay is an electromagnetic switch. So How it works, you have an electromagnet and you have an open switch. So when it is connected, when there's a current in the first part of the circuit, this will magnetize. When it will magnetize, it will close the switch for the other part. So it uses the magnetic effect of the current. So relay, loudspeaker, and electromagnet all uses the magnetic effect of the current. The potential divider does not use the magnetic effect of the current. Is it clear? This one? Yeah, relay, like example, how a relays work. The working principle of a relay. Look, for example, we have the two circuits are there. Let's say we have a thermistor and we have
Sir, what does a relay do?
a thermistor is there and we have a fixed resistor. And with this fixed resistor, we connected a relay. And there's a lamp and this is a high voltage supply. So how it
Sir, I have a
works?
question. Sir, I have a question.
Who's there?
Suleiman Tariq.
So how it works? Yeah, how the relays work, the working principle of the relay. See, we have example, this is a potential divider circuit. And in this potential divider circuit, I connected a relay. Example, the temperature is high. We have a high temperature. If we have a high temperature, so what happened to a resistance of a thermistor? The resistance of a thermistor will be low. If the resistance of the thermistor is low, so the voltage will divide, like here we'll have a low voltage. In comparison, we have a high voltage here. When we have a high voltage, so as a result, what will happen? There will be more voltage across the relay and this will be magnetized. When it magnetizes, it closes the switch. When it closes the switch, the current start to flow in the circuit and this lamp will be on. That is how we use a relay. Relay is mainly to connect one circuit with another. Like working of one circuit, we want to connect with another. We use an electromagnetic switch, which is also known as a relay. Is it clear, this one? Yes, Mohammed Abdul Rahman, you have a question? No, relay is not having a magnetic field instantly. It will magnetize once there is a large current in the relay. So more current in the relay. Yeah, the main purpose of the relay is to connect the two circuits. Yes, Saim, you have a question? In the question, a light ball is held at a rest top of the cliff. So it is at rest at the top of the cliff. It is released. So when we release and it is falling through the air, eventually reaches a terminal velocity. So first, the moment we drop, what will the acceleration of this object? It will be same as the gravity, because initially when you drop an object, it will have an acceleration due to gravity. But as it accelerates, the air resistance will start to increase, so the resultant force decreases, so acceleration will decrease. And eventually what will happen? The weight is balanced with the air resistance. So when weight balanced with the air resistance, acceleration will be zero. And you will move with the terminal velocity. So they mention here it is moving or falling at a terminal velocity. So which row describe the behavior of the ball as it descend? Descend means like going down. Yeah, the question is when it is released. So whenever you calculate an expression is always calculated for a time interval. Like example, when you release something, initial velocity is zero, but after 1 second, because it has an acceleration due to gravity, so its velocity will be 9.8 meters per second. So what about the acceleration? The acceleration will be 9.8. So whenever you drop an object, initially it was zero, the initial velocity is zero. After 1 second, the velocity will be 9.8 or the speed will be 9.8. So the acceleration will be 9.8 meter per second square. Acceleration won't be zero. But when it is continue to move with the same speed, no, the velocity is zero. If this question was, what is the initial velocity of the ball? When they say initial velocity of the ball, then I will say zero. But the question is not about the velocity. The question is about the acceleration. So acceleration is always calculated for interval. You don't have an acceleration at a point. So you release the ball. So ball was stationary. Okay. The initial velocity is zero. When the ball moves after 1 second, it has an acceleration of due to gravity. So the final speed will be 9.8. So what is the acceleration of this object? 9.8 minus 0 divided by 1. So the acceleration will be 9.8 meters per second square. So acceleration of an object, whenever you drop any object, the acceleration because of the gravity of the earth is 9.8. But it reaches the terminal velocity. So what should be the final acceleration? The final acceleration should be zero. If this was the same question in exam and they say what is the initial velocity, then your answer will be counted as correct. But they did not ask initial velocity, they asked initial acceleration. That's why initially due to gravity, and then there's no acceleration because it reaches a terminal speed. So move at a constant speed. Why final is not 9.8? Because the object is moving at a constant speed. So means the speed does not change after that. So if the speed does not change, the acceleration will be zero. So this part, acceleration is zero. When the moment it is released and it fall, because see the question, it is released and fall through the air. So you release, it was zero, and as it fall after 1 second, it will have a 9.8. Yeah, so eventually reaching a terminal velocity, so no resultant force or no acceleration. So the final acceleration should be zero. So either A can be an answer or C. But what about the initial acceleration? It's a falling object. So whenever you drop an object from the rest, it will always have an acceleration of 9.8. Initial speed is zero. What is the meaning of the term terminal velocity? Terminal velocity, when the object move at a constant speed, we call that as the terminal velocity. The weight of an object is equals to air resistance, and there is no resultant force act on the object. We call that as a terminal velocity. Is it clear? In the question, two boys of equal weight sit on one side of a seesaw. Their father of weight 1000 newtons sit on the other side. The seesaw is balanced so that it moves up and down. During one part of the cycle, the father descends through a distance of a 40 centimeter. At the same time, nearest to the pivot, the boy rises 20 centimeter, while the other boy rises 80 centimeter. What is the weight of each boy? So you can consider their movement as a distance, the perpendicular distance. So if the weight of this boy is X and the weight of this one is also X and the weight of the father is 1000 Newton and the seesaw is balanced. So when something is balanced, so we can say the total clockwise moment is equal to total anti-clockwise moment. The turning effects are equal. Yeah, the clockwise. And so what is this moment? The weight of the father is 1000 and what distance he has, like during one part of a cycle, the father descend through a distance of 40. So he descend through a distance of 40. So his distance will take as 40. At the same time, the nearest boy pivot rises through 20 centimeter. So for this one, what is the moment of this boy? X into 20. Why X into 20? Because X is his weight and the distance is 20. What about while the other boy rises 80 centimeter. So it will be X into 80. And we just compare the clockwise moment is equals to anti-clockwise moment. So it will be 1000 times 40 is equals to X into 20 plus X into 80. So 1000 times 40, so it will be 40,000. X into 20, 20x plus 80x. So this is equals to 100x. So 100x is equals to 40,000. Just x is 100 is multiplied, other side will be divided. So 40,000 divided by 100. So 0 cancel with 0. So what is the value for x? X is equals to 400. So we have to use the concept that the clockwise moment is equals to anti-clockwise moment. As I mentioned, the seesaw is balanced. From this statement, we always take that it is in equilibrium. Is it clear, this one? The next is first thing you identify. What kind of device is this? What is this? An AC generator? How you identify it's an AC generator? Because slip rings are there. If it was a DC motor, then there will be split rings. When the coil is horizontal, we have the maximum induced EMF. When the coil is vertical, the induced EMF is minimum. Okay. Yes, Abdul Rahman. The last question, okay, I'll repeat the last question. The last question was about the turning effect or the moment. Whenever objects are balanced, you have to take a clockwise and anti-clockwise turning effects are same. So the turning effect produced or caused by the father is equals to turning effect of the boys. The weight of identical weights are there, so each is X, and the distance is 20 for this one, and distance is 80 for this one. The weight of the father is 1000 and the distance is 40 for the father. So we calculate the moment because of the father and we compare with the moment due to the boys, and the clockwise and anti-clockwise turning effects are equal. So whenever you see such question regarding the pivot, you will use the concept clockwise and anti-clockwise turning effects are same. What is the difference between a split ring and the slip rings? The slip rings are circular rings which are used in AC generator. But the split rings are rings divided into two parts which are used in a DC motor. A DC motor convert electrical energy to kinetic energy, where AC generator convert kinetic to electrical. So you can see this position, the graph for AC generator, what will happen when the coil is exactly horizontal? Maximum induced EMF, then it decreases, then again it increase, then decrease, again it increase, then decrease. So when the coil is horizontal, these are the position. And when the coil is vertical, induced EMF is 0. So in the question, the graph shows a potential between X and Y against the time, indicates that X is more positive than Y. So means X is a positive one and Y is a negative one. When the coil is horizontal, when the coil is horizontal, maximum induced EMF. When the coil is vertical, minimum induced EMF. So indicates that the X is more positive than Y. Like X is a positive terminal, Y is a negative one. Okay. And you can see the coil. Which diagram shows the coil at a point on the graph? Why though? Because there is a greater change in a magnet. Why the coil horizontal? Because there is a maximum change in the, if you compare the positions, you have a magnet, north and south. So when the coil sweep from vertical position to horizontal position, there is a maximum change in the magnetic field. It is closer to the poles of the magnet and the maximum change in a magnetic field. That's why the EMF induces more when it moves from position A to B. Now, if you see the position, see, this is a position like if you see the slip rings, the graph shows a potential which is plotted for like a positive value of a potential indicate X is more positive than Y. So this is how it looks like initially. Okay. And see the position of the slip rings, like the rotation of the wire, the coil. So this part, now what will the direction of the current? The wire is moving in this, the coil is rotating in this way. If I want to find the direction of the current, what is the formula to get the direction of a current? We use a right hand rule. For AC generator, so for a right hand, for AC generator, we'll use a right hand rule. What is the right hand rule? Your index finger or your first finger represent the direction of a magnetic field. Okay. So what is the direction of a magnetic field? The direction of a magnetic field is from north to south, so towards the right hand side. Your second finger represent the direction of the force. We don't know the force right now, but we can use the thumb to know the direction of a deflection. Which direction this side is going down, and this side is going up, because the coil rotation is shown here, that it is rotating in this manner. So this side is going down and this side is going up. So what is the direction of induced? The thumb, if I say the side, like example, if this is A, if this is A, this one is B, this one is C, and this one is D. So what is the direction of the current here? For A, B, C, D. Like when you work out the right hand rule, your index finger should point towards south, which is on the right hand side. Your thumb point in the direction of the motion of the wire is going down. So your thumb is pointing down. Where your finger is pointing, your second finger is pointing from C to D. So what is the direction of the current? The direction of a current, yes, from A to B, like it's like this when you apply the rule. the right hand rule, the direction of a current in this way, okay? According to the figure. Is it clear how I work out the direction of a current? My index finger point towards south. My thumb is representing the direction in which the wire is moving. And my second finger represents the direction of a current, which is from C to D. According to the second finger, we know the direction of the current. Now, when we apply, so this is the direction at this moment when the coil is attached like this, the direction of the current is like this, the conventional current. This is A, B, C, and D. So the direction of the current is from A to B, B to C, and C to D, according to this position. And means the current is going into this position X, position Y. This is a split ring Y, because this one is connected with the Y and this one is connected to X. So current is going in this direction, this way. This is the actual motion or the movement of the current. Now the question they asked, the graph shows the potential between X and Y plotted, the voltage is plotted. And the value of the potential indicates that X is more positive than Y. So this is representing like the position of X and Y. Now, what we want, which diagram shows the coil P on the graph? Like, so P should be what? This is showing a high voltage. So means the coil should be horizontal. Either A can be an answer or C can be an answer. Because high, if they mention these points are representing the coil is exactly horizontal. If the coil was vertical, then these are the points refers to a vertical position of the coil. Now, when we check the direction, because in the beginning, they already specify that X is positive and Z is negative. And what is the direction of the current? It's going A, B, and then going to Y. Now, when you see, like with reference to this one, so if we change the direction of the current, we have the split rings. So if it is connected in this way, it means it has rotated how much? It has rotated 180 degree out of the phase. The position, because when this is connected here, the part is connected here. And if you see the figure, this part is connected here. So means what happened to the coil? The coil has rotated, if you compare the two figures, the coil has rotated 180 degree out of the phase. So it was 0 and it rotated 180 out of phase. So if this was producing like 6 volts, if this was producing 6 volts, then what this will produce after 180 out of phase, so this will produce minus 6 volts. And what this is representing the same position. Like, see, this position resemble with this one. This position resemble with this one. So it means it is resembling the same position of the coil. As it resembles the same position of the coil, so means the voltage produced should be same, identical. So position P is a negative, so the graph. Look, the diagram shows an AC generator. The graph for a potential between X and Y is plotted against the time, and the potential is positive, indicate X is more positive than Y. Like X is more positive than Y means the direction of the current. That shows how the direction of the current, the flow of the current or flow of the charges. So if X is more positive than Y, what it shows the direction of the current is like this, okay? And that is what we calculated, like according to this position, A, B, C, D will be there. Now it is -1. Now what has happened? The point P is what? Yeah, B is, look, when the coil rotated 180 degrees in an AC generator, the direction of a voltage changes. Like if you have a coil and we have a side A, B, C, D, which is horizontal. And we have a north and the south. If this produces the horizontal position, produce 6 volt. When we have this opposite side, like example, north and south, and this is CD and this is BA. So this is ABCD. So what will happen to the voltage? How much voltage it will produce? Yes, sure. I will repeat. Look, in this question, there is a coil in AC generator. I'll come to the AC generator point. Just this is an AC generator, alternating current generator. What will happen when this coil, this one is an axle, we have the slip rings. When this coil will rotate, there's a change in the magnetic field. And because of this change in the magnetic field, what it does, it induces EMF. And we use the right hand. So as you can see, the position of the coil as it is rotating. So when the coil is exactly horizontal, two ways it will be horizontal and the voltage induced will increase. So when it is horizontal first, the needle will deflect, like maximum deflection is there. Let's say this is +6 volt. And when it is again horizontal, the needle will deflect in opposite direction. So it will be -6 volts. So same thing happens. So whenever you have an AC generator or a coil of AC generator, the change in the magnetic field induces EMF. So like this is the diagram shows an AC generator. When the coil is in the position, the output is +10. See, this is representing this position of the difference between a slip rings and the split ring. Slip rings are used in AC generator to take out the current continuously from the circuit, where split rings are used in a DC motor to change the direction of the current every half cycle. So when you see this, this position is connected here and this one connected here. They mentioned the coil has a position as shown. It is +10 volt. So when they represent this position, the coil is representing a +10 volt. When does the output voltage will be -10? So when the coil will rotate 180, how the connections will change? Means this point, this position will be here. Like how the connections will change for the coil. So this position, when it will rotate, this will be here and the other one will be here, the long one. That is when it is 180 out of phase or it. So in that case, when it rotated 180, that's how the position will change. Like the small one is represented with the first and the large one is represented with the second. They will remain in contact throughout with the same slip rings, but the position will change. Like the small one will be now on the right hand side and the large one will be on the left hand side. So the voltage output will be opposite. Like this is also representing the same question. So the idea is that whenever it rotated 180 out of phase, like here it is in contact, the small one is in contact with the left and the right one is in contact with the large one. When the coil will rotate 180 degree, and let's say this position, the voltage was 10 volts. So when it rotates 180 degree, what will the voltage output? It will be minus 10 volt. The small one, as it rotates, the small one will be there with the first one and the large one with the left, but the position will change. The position or the point of the contacts will change. If it is on the left hand side, it will be on the right. And if it is on the right hand side, it will be on the left hand side. So for now, for this question, the multiple choice question, see, we have these positions. We have the position of X and Y. Okay. Yes, Simon. How we can tell the coil is positive or which side is positive or a negative? How you can identify that is by the direction of the current. From the direction of the current, you can identify whether it's positive or negative. Let's say when we work out the direction of the current for this one, this side is going down, this side is going up. So when I use a right hand rule, what is the direction of the current? This is the direction of the current. So current is going in this way, like this is the direction of the current. And they mention X is positive and Y is negative. So what is the direction of the conventional current? So it is out from positive and into negative. So this is representing the correct direction. So using a right hand grip rule, then X thing is going right. Why it will go right? Because when it rotates 180 degree, what will happen? The position will change. The smaller side will be on the left, like this side will be on the left hand side and this one will be on the right hand side.